Hey to you students, I hope you are doing fine and I hope you've been following through these lessons. It has been so interesting. Perhaps you've missed any of them. This is what we have done so far. So perimeter of plane shapes was first, area of plane shapes, then last time was three-dimensional shapes, and I believe you enjoyed that lesson. Now, this week we are going to be looking at volume. Volume is just related to three-dimensional shapes. We don't find volume of two-dimensional shapes. We don't find volume of plane shapes. So you get your textbooks and let's start right away. The objective of the lesson is that by the end you will be able to make and draw the net of three-dimensional shapes. Then you'll be able to identify the basic unit of volume and convert between the different units of volume. You'll be able to calculate the volume of cubes and cuboid by direct calculation, and we are going to be or you'll be able to calculate the volume of right angle triangular prism. Okay, so we go with the content. The first is nets of three-dimensional shapes, and second is the volume proper. Now let's look at the nets. Last week we looked at the characteristics, properties, features of about 7 three-dimensional shapes, and in that lesson we were able to by the number of faces, edge and vertex, you are able to know or determine the characteristics of these three-dimensional shapes. Now, net has to do with you. How does these shapes, how do they look if they are open out flat? If they are drawn on plane surfaces. For instance, you have seen a box, let's say a box of Indomie before. A box of Indomie is a cuboid. By the time you open it flat, you cut out the glue, the sellotape and everything. By the time you open it flat, that's what we call the net. So, and that's how we produce these shapes. So net has to do with how these shapes looks like when you open them flat. Okay, so net can be folded up to make a 3D shape. We can as well fold that carton of Indomie back. When we open it flat, that's what we call the net. When we fold it back, that's what we have the 3D shape back. Now you can also draw the net on a paper and fold it on into the shape, and that's what I will require you do. Get a cardboard paper and cut out the nets. Cut out the net on the cardboard paper and fold it into the shape. Now I would like you to go to page 230 of your textbook. You will see the nets. Because of the limitation of this space, I can't put them up here for you, but it's inside your textbook. You go to page 230, you will see about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. About 10 of them. So at least you should be able to do for cube, for cuboid, for cylinder, for cone, for square base pyramid, for tetrahedron, hexagonal prism, and and rectangular base pyramid. You should be able to do the net of those shapes, and you fold them back. You fold them in shape back. Then you do what they do in the industry by producing cartons. So that's what we mean by the nets. Okay. So we go to volume now. We go to volume now. Now, the volume of an object is the amount of space occupied by an object or substance. The amount of space it occupies is different from area. Area has to do with plane surfaces, but volume has to do with the amount of space it occupies. The amount of space your classroom occupies in the entire school compound. That's what we mean by volume. The amount of space it covers has to do with the length, the breadth, the height, and every other dimensions. So that's volume for you. Now, let's look at how we calculate these volumes. We can calculate using the direct calculation, I mean the formula, and you can also calculate by counting small boxes. You know the dimension of the small boxes, then you calculate it. But what we are going to be doing in this lesson is to use the formula as we did in the last lesson to calculate. But before we calculate, I need you to understand that there are units of measuring volume. Just like we have units in measuring area, centimeter square, meter square, millimeter square, we also have in volume, we are now dealing with cube raised to power 3. We call it cube sometime. Some persons also call it raised to power 3 cube. It's either you say cubic meter or you say meter cube, either way. So the cubic meter is the basic unit of volume. That's the basic unit we use in finding volume. Now, you recall that 1 meter is 100 centimeter. So 1 meter cube will be 1 meter times 1 meter times 1 meter. Meter times meter times meter will give you meter cube. You get that? So now, and you remember, you know that we said that 1 meter is 100 centimeter. So bring it down now. 1 meter is 100 centimeter. 1 meter is 100 centimeter. 1 meter is 100 centimeter. Put that together now. Put all these together. You have 1 meter is equals to 1 million centimeter cube. 1 meter cube is equals to 1 million centimeter cube. So you take note of this. If you are asked to convert or express your answer in centimeter cube and it was initially given in meter, you multiply by 1 million. If you are asked to convert or express in meter cube, you divide by 1 million. Going this way to meters cube, you divide by 1 million. Going this way, you multiply by 1 million. We have seen this several times in the course of this lesson, so it should not be strange to you. And the other one is 1 centimeter to 10 millimeters. 10 millimeters make 1 centimeter. You know the way we read it. Now, 1 centimeter cube will be 1 centimeter times 1 centimeter times 1 centimeter. So by the time you put in this now, you have 10 millimeters times 10 millimeters times 10 millimeters times 10 millimeters, which will give you 1000 millimeter cube. So take note of these two in red. We use them in converting from either form of given unit. Okay, so take note of that. Take note. Now, let's get to the calculation now. And there are two formulae for us here. Now, the first is for cube and the second is for cuboid. And you recall how a cube looks like. A cube only has lengths. All sides are equal, because all the faces are square. You remember? Okay, so L, those are the dimensions. So what's the formula for calculating volume of a cube now? It's very simple. You know it. The volume is length times length times length. Length times length times length. Now, length times length will give you L times L times L, which is L cube. L raised to power 3. L raised to power 3. You take note of that. Now, for cuboid, that's the difference. We have length, breadth, height. LBH. Length, breadth, height. So volume now is length times breadth times height, and which will give you LBH. Cube, L cube. For cuboid, LBH. So take note of it. These are the formulas used for calculating cube and cuboid respectively. Let's see some calculations now. Simple calculations. A room is 6 meters long and 4.2 meters wide and 3.2 meters high. What is the volume? Long, wide, high. Length, breadth, height. So there you go, and you sure know that this is a cuboid because it has length, breadth, and height. Okay, the second question is, a cube is of side 23 centimeter. What is the volume of the cube in meter cube? Okay, let's go with the first. Understand that the length is 6 meters, the breadth 4.2, the height 3.2. Now, deal with it. Volume is length times breadth times height. We are using this volume because these dimensions relate to a cuboid. Okay, so when you calculate, just put in the dimensions and you compute. You have your volume to be 80.64 meter cube. Meter times meter times meter. This is multiplication. Meters times meters times meter will give you meter cube, not just meter. Okay, so that's how we calculate the volume for the first question here. Then the second question, I have a sketch for you there now. You see, all sides, because it's a square, the faces are square, so 23, 23, 23, 23, 23, 23, 23, just round about like that. Now, a cube is of side 23 centimeter. Find the volume. What is the volume in meter cube? Take note. Look at the unit given, centimeter. Now put your answer in meter cube. This is not a typo. This is not an error. Don't say this is an error. No. You are asked to do that conversion I mentioned earlier. Now let's calculate the volume first. The volume of the cube is L cube. You remember, you should be familiar with it now. L cube means L times L times L. 23 times 23 times 23. And when you compute that will be 12,167 centimeter cube. Don't be funny by just taking away this C. No. You must do the conversion to get it to meter cube. Now, what's the conversion factor? 1 meter cube is 1 million centimeter cube. I showed you how to get that in the last part before coming in. Now, what will you do to take this to meter cube? Is in centimeter cube now. What will you do? Will you divide or multiply by 1 million? Sure, you are going to divide. So by the time you divide, how many zeros here? 6 zeros. So right from this point here, it goes back. The way we divide. So we divide, the decimals move 6. The decimal point move 6 times backwards. You remember, we are dividing, so it goes backwards. Now When you do all of that, you have the answer to be 0.01217 meter cube, and that's the volume in meter cube. I believe you understand this. Okay, so we go on. We have what we call capacity now. Capacity is the amount of liquid a container can hold. The capacity of a container is the amount of liquid it can hold. You have heard of give me that 50 cl water bottle. I need the 50 cl ever water bottle. We are talking about capacity. The amount of liquid it can hold, that's capacity. Volume is the amount of space it occupies, while capacity is the amount of liquid, either kerosene tank, either water tank, either fuel tank, whatever has to do with capacity. Now, you need to understand that liquids, water, petrol, kerosene are measured by capacity. You have seen that fuel tanker, they will put there 33,000 liters, because the unit of capacity is liters, L. So 33,000 liter. You have seen 25 liters. Give me that 25, that jerry can, that gallon you use for buying fuel is measured in liters. That's capacity. Okay, so the standard unit for volume, remember, meter cube. A meter cube, you can move from centimeter cube, you can move to millimeter cube, but in capacity, we deal with liters. Now, you need to understand that you can also move from volume to liters. You can move from volume to liters. And what is the relationship? 1 meter cube, just 1 meter cube is 1,000 liters. 1 meter cube is 1,000 liters. 1 meter cube, just 1 meter cube is 1,000 liters. Okay, take note of this also. I should put that in red for you so that you take note of it, but it's fine. Take note of it, circle it in your notes, circle it. I believe you are writing all these things in your notes. You have your notes, you write it there. Now, 1 meter cube is equals to 1,000 liters. Now, the second is 1,000 centimeter cube is equals to 1 liter. They both two are different. So we use the first in converting from meter cube to liters, and we use the second for converting from centimeter cube to liters. So either way the question comes, take note of these two. So let's see how it works. Let's see it in questions below. Work examples. Now, the first, find the capacity of a water reservoir. The one that always sits on top of the house. The water reservoir, 9 meter long, 6 meter wide, and 4.5 meter high. So you have, as we saw in the other example, length, we have breadth, we have height. So find the capacity. Take note, you are not asked to find volume, find capacity. But you can't find the capacity without finding the volume first. You can't find the capacity without finding the volume first. So let's work that out. Of course, you know that this is not a cubic tank. This reservoir is not in the shape of a cube, because by the observation of the dimensions, you see they are not the same. It's not 999. This is 964.5. So you should know they are not the same. This is a cuboid. Okay, now, so what formula are you supposed to use? L cube or LBH? You are supposed to use LBH, and that's what we are going to use here. So volume of the reservoir is cross-sectional area, LBH, cross-sectional area times height. Why am I mentioning cross-sectional area? Of course, you should know that area is length times breadth. So you can also be asked, what is the cross-sectional area? Cross-sectional area is the multiplication of the length and the breadth. Okay. If we are asked to calculate the area of this tank now, we will have just compute 9 times 6, and that's 54 centimeter. Meters, meter square. Okay, that's the area. But volume is LBH, and LB is area on its own, because it's a rectangular tank. Okay. So let's compute now. We have 9 meters times 6 meters, yes, times 4.5, because that's the height. This is the height. So by the time you work that out, you have 54 meter cube. Where is meter cube coming from? Meters times meter, you have it here. Then 54 times this, you multiply, you have 243 meter cube. Make sure you put your unit. Now, what is the capacity? That's the question. What we found so far is just the volume, and we are not asked to calculate the volume. Make sure you read the question and read it again. Understand what you are asked to do. So how do we find the capacity? Just by converting. There is no, in quote, formula for capacity. There's no formula for that, but you can move from volume to capacity. Okay, so 1 meter cube is 1000 liters. Liters has to do with capacity. Liters, capacity, meter cube, volume. So what you are expected to do is to do a conversion here. Move from meter cube to liters, because this answer is already in meters cube. So how do you move now? How do you move? Will you multiply by 1000 or you divide by 1000? Sure, you multiply by 1000. You are converting to liters. So let's work that out. We have 243 meter cube equals to 243 meter cube times 1000 liters. Now that will give you 243,000 liters. So that's the capacity of the reservoir. It can be an underground reservoir, it can be an overhead reservoir. So that's how we calculate capacity. So take note of the conversion factor. In fact, I want you to hold it just like you know 100 centimeter is equals to 1 meter. You should know this relation, this conversion factor also. Okay, let's see if we have another one. Yes, we have. Okay. Okay, we go to right angle triangular prism. Right angle triangular prism. I need you to pay attention here. Now, remember that a cuboid, you have a cuboid, like this is a cuboid, right? Yes, this is a cuboid. Now, a cuboid has the volume formula. We have seen this in the last part. LBH, length times breadth times height. Now, if this cuboid, if I cut it into two equal right angle triangular prism, if I cut it, let's say I get a scissors or something and I cut this cuboid. Look at the manner in which I'm cutting it. Across diagonal, yes, across the top face diagonal. Let's cut it again. Let's cut it again, please. Okay, so when you cut it, you have one part. You see, you have one part there, then you have the other part there. It's just like you are slicing your pizza, So by the time you cut it, that's what you have. Now take note, for the whole cuboid, this is the shape. This is the formula I mean. This is the formula. Now, by the time you cut the cuboid into two parts, of course they are equal, two equal parts, you will now have, for this alone, you have half LBH. Are you there? Of course, it's the half of this, So this also will be 1/2 LBH because they are half. So by the time you join them together, you have a full cuboid. 1. Are you there? Okay. So these two shapes, these two, is what we call right angle triangular prism. Oh, don't forget we said that prisms have their top and base face to be the same. So triangle on top, triangle at the base. So this is a right angle. Of course, you know that the angle across the angle at this corner, at this corner, at this corner, at this corner is 90 degrees. So this is a 90 degrees. This means 90 degrees. Right angle means 90 degrees triangular prism. So what I'm trying to say is that the formula for calculating a right angle triangular prism is 1/2 times length times breadth times height, and that will give you V equals 1/2 LBH. So take note, circle it in your note. Volume is 1/2. Volume of a right angle triangular prism is 1/2 times length times breadth times height. Take note of it. Take note. Okay. Now let's use that to solve one or two questions before we end today's class. Now, calculate the volume of the prism and look at the prism we have here. Of course, you should know that this corner, even though it isn't there, you should know that this corner is 90 degrees. So this is a right angle. Look at this face. Here is the same as this face here. So, in prism, we have the two faces to be the same, the top and the base face. So I can make this standing now to be resting on this face, and this other face will be up on top. So how do we calculate the volume of this prism? I told you already that it's a right angle triangular prism. So even though the question did not state right angle triangular prism, from the diagram you should be able to know that this is 90 degrees and this is a right angle triangular prism. So you use the formula I showed you earlier, and that would be 1/2 LBH, and you compute 1/2. L is 4, this part is 4, then this part is 5, yes, and this part, if we rotate it, if it's sitting on this part now, which is the base face, this will be the height. So that's why here is 10. Okay, now, so when you compute, you cancel out. I believe you can do that. 2 here 1, 2 here 2, 2 times 5, 10, 10 times 10, 100 centimeter cube. Centimeter times centimeter. You see, I'm emphasizing the unit. You should put your unit. That makes the difference between a linear measurement or an area measurement or a volume measurement. So put your unit. Now, that's how we calculate that. Then we have one last one before we call it a day today. Calculate the volume of the solid below with a cross section, take note, having the shape of a trapezium. Calculate the volume of the solid below with a cross section having the shape of a trapezium. So that's what we are to calculate. Now, I intentionally put this face to be black, so that I need you to see that this face is a trapezium. This face is a trapezium. So you need to take note of that. Now, How do we calculate the volume? I did not give you the formula for calculating this. I did not give you, but from what we did in the last part, in the other example, you should be able to calculate for this. Now, how do we do this? Of course, you should know that this is a prism also, because the base, look at this face, is the same as this face. Is the same as this face. You know, I should shade this. You know, this side face here. So if I turn this face downwards, if I make it lie, if I make the shape lie on this face will be on the top. You know. Okay, so this is a prism also. Now that means this is the height. Are you there? And you know that this trapezium has two parallel sides, 8 centimeter and 12 centimeter, and this is the height. Are we together? Okay, so how do we calculate that now? Area of cross section, this black part, you know, area is, you remember this formula, 1/2 parallel sides, sum of parallel sides, times height. This is the height of the trapezium. This part is the height of the trapezium. So parallel sides, 8 plus 12, that's the parallel sides, sum of parallel sides. So we have 1/2 times 20, 8 plus 12, 20 times 10, you know. So by the time you work that out, you have 100 centimeters square. Why? Because it's just the area of this face. This is not a mistake. This is just the area of this face. This face here, you can see this black part. Okay, now how do we find the volume? Now the volume now has to do with the height, the amount of space it occupies. Now you now bring in the height. So in calculating the height now is area times the height. This should be height. I beg your pardon. This should be height. So the volume now is area of the cross section times height. So the height here is now 16. You know, I told you when this lies on this face, this will be the top part, and this will be the height. So that would be 100 centimeters square times 16 centimeter. 16 centimeter is this. So when you compute that, you will have your answer to be 1,600 centimeter cube. Make sure you put your unit, and that is the volume of this solid, which is also a prism. All right, so that does it for today's lesson. I believe you enjoyed the lesson, and I would like you to try your hands on these questions. I said this in the course of the lesson. Use a cardboard paper to make nets of the 7 shapes listed in the lesson, and thereafter fold them into their respective shape. Okay, I would like to see that when we see. Then you go to page 238. Just deal with question 5, 8, and 9. They are cheap questions. They will not take much of your time. Then question 1D, 2D on page 240. Page 240, you still see question 6 and 10. Take note on this number 4 and number 5. You go to page 242, you will see question 2 and 6. Try your hands on them, and you'll be so perfect on them. So this is the end of this lesson. I hope you enjoyed it once again, and I'll see you in the next lesson. Thank you.